Hello, math humans. We're going to do 4.1b today. We're going to be doing more work with antiderivatives. So our objectives are that we're going to be solving differential equations. So I'm just going to start with an example that says example, and I want to do the integral of the sine of x over cosine squared x dx. Remember, we talked about there's no product rule, there's no quotient rule, so I need to manage this. I'm going to split it up a little bit. So I'm going to turn this into the sine of x over the cosine of x. I split up my cosines times 1 over the cosine of x and then dx. So then this is the integral of sine divided by cosine is the tangent of x. 1 over cosine is the secant of x dx. I would go back and check my handy-dandy sheet and see that this is already just an integral, and it is the secant of x plus c. So the integral of f of x dx is the secant of x plus c, because there was already a rule for that. If there's not a rule, then I have additional math that I need to do. We've got kind of a weird shadow today. All right. So the things I want to talk about is if I'm taking an antiderivative of a function, okay, and I'm doing this, we've talked about it generates a series of solutions. And so here's what I'll show you. I'll illustrate this. Sorry, brain and mouth aren't working at the same speed. I'll illustrate this by an example. So let's say I have y is equal to the integral of 3x squared minus 1 dx. Well, when I integrate that for y, I'm going to get 3x to the third over 3 minus 1x plus c. So y is going to equal x cubed minus x plus c. This is called the general solution. And here's what that actually means. So it means that x cubed minus x basically is going to be something like this. The plus c means that it is creating a family of problems, right? And so that just means it's the same curve that is shifting up or shifting down. And so the general solution is going to be just a series of graphs that are related by a vertical translation. So that's actually kind of cool. All right, move my coffee cup because he's in the way. All right, so let's say I have dy dx is 3x squared minus 1. This is called a differential equation. And let's say I needed to solve this. Then I would take the dx to the other side, so I would get dy is equal to 3x squared minus 1 dx. The goal is to solve for y, which is why it's called a differential equation, so I'm going to integrate both sides. Yes, you have to take the time to write your little integrals, and then you would get y is equal to, and this is a problem we've already done, 3x cubed over 3 minus 1x, and then plus c. And then that's how we would have gotten x cubed minus x plus c, all right? So this is called the general solution of this differential equation. The other option, let me write that down just to make sure that you have it. This is our general solution. And remember, technically what that means is that I have a family of solutions all differing by a vertical stretch factor. The next application of this would be a particular, C-U-L-A-R, a particular solution. So that means instead of having a family of curves, I am looking for one precise solution. So that means that I would get y is equal to x cubed minus x, and I'm just going to write a number. So that means that I would actually find the value of c. And so it would generate one specific curve. So let's do an example. So for the first example, it says find the general solution of f prime of x is equal to 1 over x squared. Now this one looks a little bit different than what I've done in the past, okay, because instead of saying dy dx, it says f prime of x. So I could just rewrite this as dy dx, and I'm going to rewrite it as x to the negative 2, because I know I'm going to have to eventually. I'm going to cross multiply. You don't want to put an equals here. You want to show that the work is progressing, because if I have an equals where the statements aren't actually equal, that makes your AP readers a little bit cranky. So I would write dy is equal to x to the negative 2 dx. I'm going to integrate both sides. On an FRQ, oftentimes you get a point just for separating the variables, and then you might get another point just for showing that you're going to integrate both sides. So the details of calculus are very, very important, and it's easier to boost your AP score just by showing the little steps of what you're doing. So now when I integrate dy, I'm going to get y is equal to, and then if I go up 1, it's going to be to the negative 1 divided by a negative 1 plus c. I would write y is equal to a negative 1 over x plus c, and that is, I'll write it over here, my general solution. Okay. Alrighty. What if, on the other hand, I said find the particular solution if f of 1 is equal to 0, okay? So then what I would do is the way this particular problem is written, remember the antiderivative is f, okay? And so I would say 0 is equal to a negative 1 over 1, because that's my x value, plus c. And so then I would solve for c, and I would get c is equal to a negative positive 1. Bad math, I made a mistake. It's funny when I catch my own mistakes. So now for the particular solution, then that would be y is equal to a negative 1 over x plus 1. Alrighty, that was pretty easy. So now let's do something that's a little bit more physics-based, just because that will be fun. So example 2 says, before it says anything, we're going to actually develop a beloved physics y equation. I'm not sure that you guys think of them as beloved, but I think they're very fun. So here's going to be our problem. A ball is thrown upward with an initial velocity of 64 feet per second from an initial height of 80 feet. The first thing that we want to do is we want to find the position function, and then the second thing, B, is when does the ball hit the ground? So when does the ball hit the ground? Alrighty, so if we write down what we know that the initial height, so S of 0, is equal to 80 feet. And so this is our initial height. We know that S prime of 0 is going to equal 64, and that is the initial velocity. And we know that S double prime of t is equal to a negative 32, and this is the acceleration due to gravity. And this is one of those constants that in physics, you know, if I'm working in feet, it's a negative 32 feet per second squared. And then I use other constants depending on where my party is happening. So now I'm going to write an equation. I'm going to say that the velocity is going to equal the integral of acceleration dt. Okay? Alrighty, and I know that value, so I'm going to say that this is equal to the integral of a negative 32 dt, and when I integrate, I'm going to get a negative 32t plus c. So I know that the velocity is equal to a negative 32t plus c. Remember, we showed that my initial velocity was 64, so I can say, and I'm just going to write this right here again, is equal to 64. I can use this to solve for c. So a negative 32t plus c is going to equal 64. And then my initial time was 0 plus c is equal to 64. So c is equal to 64. Okay? So now I know that s prime of t is equal to a negative 32t plus 64, and this would be my particular solution, right? Remember, it says find a position function. Well, if this is velocity, then position s of t is going to equal the integral of s prime of t dt, so that's going to be the integral of a negative 32t plus 64 dt, okay? And when I do that math, I'm going to get a negative 32t squared over 2 plus 64t plus c, okay? Alrighty? So my s of t, my handy-dandy equation, is a negative 16t squared plus 64t plus c. I think this is really cool. This is your projectile motion equation. There's your gravity, right? 64 was your initial upward velocity. So now I need to solve for c, and I'm going to use s of 0 was equal to 80. So then I'm going to get 80 is equal to a negative 16 times 0 squared, 64 times 0 plus c. And so I get that c is equal to 80. Okay? And we're almost done, at least with a. And so my position function is going to be s of t is equal to a negative 16t squared plus 64t plus 80. That's really cool. Alrighty? So that's part A. The B part says, when does the ball hit the ground? Well, the ball hits the ground when its height above the ground is 0. So then I would just take my negative 16t squared plus 64t plus 80, set it equal to 0. I'm going to use the quadratic program on my calculator because I'm a little bit lazy, and then I would get t is equal to 5 seconds to hit the ground. And so there we go. So I would finish this. Time is 5 seconds to hit the ground. And now I have answered all of the questions that I was given. That's it for today. Kind of cool. Yay, physics. Talk to you soon.